good afternoon for everybody. I think that wraps everybody across the globe. I would say, I would think, at least at this time of day. Um, Again, I'm Jose Andres. Thank you, Danny, for that introduction. I'm currently in Belgium, working for a consulting company named Initum, and it's been quite a journey. So I had this opportunity today to present about Azure Chaos Studio, and let's just get to it. So let me share my screen very quick. All right. So before we start, of course, I want to give a big shout out to the sponsors that, of course, without them, this event wouldn't be possible. And these online events usually are very good. I like them personally because even though that when you are live and you can talk to the speaker directly, it gives you a little bit more time to soak in the information when it's given in this fashion. At least that's what I believe personally. Okay, so to start, even though that this is a presentation, a session about chaos engineering, I wanted to talk a little bit about football. Okay, so I'm a very big fan of eFootball. For those who don't know, eFootball is an online game that you can play on your console, whether that be PS5 or Xbox, or even on your phone. I personally play it on the phone when I have just a few spare minutes in my day just to play a quick match between my favorite teams. Um, and I wanted to talk about eFootball specifically because even though that it can be considered as just a game, it's actually a very complex system. Okay, so eFootball and FIFA, they're the same game in spirit, right? But they're a little bit different in the features and even in fandom, right? But in general, these types of games have these kinds of features that you see on the screen, right? So there's matchmaking, right? So these games give you the ability to play an online match, an online game with somebody in some other place in the world. So it bridges two people to do that. It enables real-time gameplay, right? So you can play using your favorite teams and your favorite players, and it's done in real time, right? You also have player stats and teams, so it's very neat. It's a very neat feature because it makes it feel very real. How you can see when a player didn't perform very well over the weekend, how their stats drop, and that has an impact in the game and ultimately in the team that you have in there. And of course, that applies for teams as well. If a team lost in the quarterfinals of a tournament, that's going to be reflected in the stats. So that's also something very neat. Microtransactions and My Club. My Club is the fancy name that eFootball gives it, but FIFA has the same feature with a different title, where you can buy these very special assets that can make your experience as a gamer very easy, or at least easier, right? Than if you just use the regular assets in the game. And by that, I mean purchasing the best players that are available in the market, or maybe you want to add these special add-ons to your players to give them a little bit of an extra edge in matches. Maybe to make them quicker or to be able to make a pass with more precision, that kind of thing. And in addition to that, you also have game updates. So if you're a football fan, you know that the Club World Cup is going on right now, and these games take advantage of that, right? They present an offering where you can simulate as if you're playing in that tournament, being one of the teams in the game. And of course, if a player is out due to injury, that also gets reflected in the game. So it's a very it's a very real, quote unquote, experience of what happens in the football world, right? So these are all the features that eFootball and FIFA have in particular, right? And if you think about it, those are very, very, very complex features, and there must be a very complex architecture behind the scenes to be able to, to enable these kinds of features, right? So in the case of matchmaking, right, you have your client. In my case, I play using my phone, but you could use a console. So that's something that you have to take into account. You also have the matchmaking servers, right? So the servers that actually take care of linking the two players to be able to play the game, and that has to happen in real time, right? You also have the game servers that process millions and millions and millions of events to reflect the commands that you are, that you are setting off in your console, to that be reflected in the game. Maybe you have Mbappe coming into the box at a very high speed, and you need the goalkeeper to come out to try to close the gap, right? Those are events that they have to be processed very, very quickly to give a good experience to the player. You also have databases, right? So where all of those player stats, team stats are lodged, where they're stored. And you have payment services, right? When you want to buy, a legend, or maybe, a neat asset for your team or a player. And all of these features have to be held or supported in some kind of cloud infrastructure, right? So that you can be able to plan with your friends that maybe are in another region, in another country, or maybe even another continent, right? So even though that it's you could say it's a silly game, there's actually a lot going on behind this. And since these games have to be using some kind of cloud infrastructure, right? We have to talk about how, if you want these players to have an experience that's enjoyable, they want to connect to the nearest region, right? Or to the nearest server, so that there's the least amount of latency possible, and overall the game performs efficiently. Okay. And this happens for eFootball, FIFA, and online gaming in general. And that sounds very, very well and neat, but what happens when things go wrong in that cloud infrastructure that you have? Well, multiple things can happen, right? You're going to have high ping and lagging matches, right? Which is due to network congestion and overloaded game servers. Your matchmaking takes forever. So in my case, I just have maybe a few minutes to play a match. And if it takes 10, 15 minutes to connect to another player, then it's a very frustrating experience, right? Maybe I'm playing in a very important tournament. I'm playing the final of the UEFA Champions League, and I'm winning 3-2 in the 90th minute. Suddenly, there's a disconnection mismatch. So that might be to the packet loss, or maybe a failure in the region where that game is being lived, to say it in a way. Or maybe I'm buying a legend, I'm buying Diego Maradona, or I'm buying Pele, and there's a database issue and my payment can't go through, right? Those are all very infuriating failures. And of course, I'm just giving some examples for eFootball, for this online game, but what if this happens in places, in sectors where the consequences can be very, very, very harsh? So to continue on that same analogy, that same example of online games, quite recently there was a PlayStation Network outage. I think it was in the month of February, where due to an operational issue, service was down, right? And to compensate for this failure, well, PlayStation gave its members a free gift. They gave, I think it was about 3 or 4 days more of their PlayStation Plus subscription, right, to compensate for that failure. But what about when it comes down to things like banking, right, and finance? So in the UK, Barclays has been hit by just this is just one news clipping that I found, but there are many, many more of Barclays and many other financial institutions where they have to pay out millions and millions in compensation after some kind of outage in IT, right? And that, of course, has very detrimental consequences to the business and, of course, you lose confidence. Your customers lose confidence, right? But then that brings the question, what if we could stimulate these kinds of failures, right? What if we could simulate failures where a region goes out or a very critical service is taken out, and we have to have our system, we have to test our system to be resilient for those failures. Well, it turns out that there was a team of some crazy engineers that created a tool called Chaos Monkey, right? These engineers were a team at Netflix. And to sum it up, to summarize it, Chaos Monkey is a tool that would randomly terminate the VMs that Netflix had in a production environment, right? And just by killing those VMs, they would simulate, catastrophic failures to see how their system, their production environment would be resilient. And these disruptions, right? These failures that the tool injected into the system, they would simulate real-world events, right? So it turns out that Azure has an offering very similar to that, and it's called Azure Chaos Studio. And it's a managed service that enables engineering teams, right, to improve their cloud applications and services, to make them more resilient, right? It injects failures that simulate outages, right? It could be either killing virtual machines, or maybe adding latency to a network, or changing the permissions, that kind of thing, into services to see how their entire environment would behave under such stress, under such failure. And this is done via chaos experiments. And we will see a little bit more about what they actually are and how we can use them, how we can design them in the Azure portal. Okay. So Azure Chaos Studio supports two types of faults. The first one is service direct. And what this means is that the fault, right, the outage that you're going to inject to your resources runs directly in Azure, right? And it doesn't require any kind of instrumentation or additional installation on your behalf. You can just open up Azure Chaos Studio, make a few clicks, select the resources that you want the faults to be injected to, and that is it, right? And I have two examples there on the slide. So it could be something as rebooting an Azure cache for Redis cluster, or maybe adding network latency to your AKS pods, right? So it's very, very easy in that sense. The other type is agent-based. And what that means is that you install an agent inside of your VMs or your virtual machine scale set to perform additional faults, right? To inject additional faults. And these could be, to apply virtual memory pressure, to kill a process, to kill a server, apply CPU pressure, and many, many more. Now, how do you execute these faults, and how complex, how eloquent can you design such experiments, right? So if you go to the Azure Chaos Studio documentation on MS Learn, you will find that it talks about selectors and logic. And selectors are basically the group of resources where you want those faults to be injected to, right? And you also have the logic, where you can define using a series of steps what you want to inject, how you want to inject it, and for how long. Okay. Something that's very important to consider here is that when designing chaos experiments, you have branches and you also have steps. And it's very easy to understand because steps are sequential, right? I want to shut down virtual machine A, and then virtual machine B, and then virtual machine C, and it does it in a sequential manner. And you also have branches, which executes tasks in parallel, right? So at the same time as VM A is shutting down, I also want to kill a service in this other server because that has some important or critical business logic for my system. Okay. Before injecting the faults, something that you have to learn is that Azure Chaos Studio has a library that's still ongoing, that's still growing, where it defines the capabilities for each resource. To put it in simpler terms, there's a library where you can see what kind of faults you can inject per resource. So for example, virtual machines and VM scale sets, you have CPU pressure, you could kill a process, network latency, a DNS failure, and many more. But for some other resources, for example, app service, you don't have a very extensive list of what you can directly inject. So for the moment, for app services, you can just stop the app service, stop the service, and that's it, right? For network security groups, you can alter a network security rule that's in place in your system. Maybe you want to open a port or close a port in that manner. And you also have capabilities for AKS, right? And this list is actually quite extensive, right? You have a network disruption, container disruption, time sync issues, and many, many more. Okay. So let's take a look in the portal. I'm going to show you very quickly how that looks like using the designer. Okay. So I'm showing the designer, the Chaos Studio resource in the portal, and you can see that you have targets and you have experiments. If you click on targets, you can select and be very meticulous on which resources you want to onboard to be able to be used in Chaos Studio, right? So these are just the resources that I have enabled for previous projects. And this is actually a very, very neat, you could say it's a feature, because if you don't onboard a resource first, you cannot use it in Chaos Studio. So you can think of it as a step, right? As a preliminary step to be able to use Chaos Studio. So you can see that you can just click the resource and enable it for service direct targets. So in the case of, for example, this key vault that I have selected, I of course can only select that. But if I chose a VM, hold on. We refresh that very quick. Yeah, it broke the portal. If I chose a VM, you can enable it for service direct and also for what do you call it, for agent-based targets. I'm not sure why this is not popping up, but just bear in mind that you can select your VM and you can enable both, okay? So for the VMs that I have here, I've already enabled them. And of course, you can disable the targets if you'd like, okay? So once you have your resources onboarded in the Chaos Studio Designer, you can go to experiments and design set experiments, right? I've already created a few because I was playing around with Azure Chaos Studio. And for the sake of the presentation, I'm going to show you the one that I've already created, but I'm not going to run it, because something that you have to consider is that when executing the experiment, it does take some time to warm up, to boot up, and ultimately run, right? So this experiment that I have here, and I'll show you, it does something very, very basic, right? So it just has one step and one branch. So it's just running one task, right? Which is to shut down a VM. It's going to shut it down for a duration of 5 minutes. And it's going to be an abrupt shutdown. Okay, it's just going to kill the instance. I've selected here the resource where I want that to happen, right? So in this case, it's for one of these VMs that I have available. And then it'll run, it'll take about 6 minutes to boot up. But what's happening behind the scenes is that virtual machines are booting up to try to inject this particular fault to the resource that I've chosen, okay? And you can see here from previous runs that usually that's how long it takes, right? So for example, here, it took about 5 minutes and 37 seconds to boot up, kill the resource, and then and to run the entire experiment per se. Okay, so that's something to take into consideration. What's important here, and this is something to note, is that these experiments will perform these actions on the resources that you have in Azure. And I know I've said that before, but what I mean by that is that you have to have a strategy of how to perform these tests, right? So if you have a production environment and you want to execute the experiment, know that it will kill your VM, it will kill your app service. So there has to be a discussion, a strategy on how to use Chaos Studio in that manner. Maybe you want to have a separate environment, a test environment that closely resembles production, where you can execute these tasks. Or maybe you want to run them in production, but you have a strategy to control the blast radius, right? Which resources are going to go down and how to act in case something fails during that test, okay? So I ran this a few minutes before. For me, right now, it's 7:25, and I ran this at 6:07. But I wanted to show how if you go to Azure Monitor, right, and you click on the metrics for that particular VM, you can see that the availability went down, right, for the duration of that test, which was about 5 minutes. Now, the neat thing here is that you can leverage Azure Monitor to use that telemetry for, for dashboards, for operations, that kind of thing, right? Maybe you want to have a report or a dashboard about how that experiment went, something that you can discuss later with your team. You can leverage Azure Monitor, application insights, diagnostic settings on your VMs or on the resources that are being targeted, and leverage that telemetry for other purposes. Okay, so that's something very, very neat to have in mind. Okay, I also want to show you how this is the fault and action library. And again, this is a growing library. Okay, so not all the resources are, of course, onboarded here, but you can scroll down and see, the types of capabilities that you have for the targets that are available. So Cosmos DB, Event Hubs, Key Vault, that kind of thing. I believe that there is going to be some added functionality for Event Hubs and Service Bus, because this is still growing, right? And the latest news, I think it was mentioned in Integrate 2025, which was just a couple of days ago, is that there are coming features for Service Bus and for Event Hubs, additional features. So that's something to be on the lookout for. Okay. So let me jump back to the presentation. So in addition to that, there are very neat use cases for this resource in DevOps. And I'm just going to highlight a few that I think are very, very important, something that you could take into consideration with clients, right? So the first is that you can leverage Azure Chaos Studio and Azure load testing together, right? So let's say that you have a web API and you want to simulate, how many requests are coming in for a particular set of endpoints, and you can use Azure load testing to simulate that high, that kind of stress, that kind of traffic in your applications. And you could also leverage Azure Chaos Studio to see what would happen when going under that kind of high stress and your infrastructure is suffering some kind of fault, some kind of failure, right? So using these two tools in conjunction is something that can be considered, and it's very neat to look a little bit deeper into. In addition to that, you have the Azure Chaos Studio REST API. At the moment, the REST API is the only tool that's available, right, to be able to interact with the different features that Azure Chaos Studio offers. So if you wanted to create an experiment, you wanted to run an experiment and see how it's going, the progress of that experiment, you can leverage a REST API that is offered for Azure Chaos Studio, right? And you can use this in your DevOps strategy, right? Maybe you want to have a few pipelines that can ease how you simulate those faults, how you inject failure to your resources. At the moment, this is the only tool that is available. You would think that maybe you would have an Azure CLI offering or maybe something in PowerShell, but that's not currently available at the moment. Okay, so what we have is the REST API to be able to communicate with the Azure Resource Manager. Okay. So, of course, the question that most people have in their mind is, how much does this even cost, right? And well, the short answer is that it's a very pricey resource, right? In my opinion, this is a kind of resource or feature in Azure that only very very large organizations would most likely utilize, right? So for example, take the example of Netflix, right? Let's say that Netflix was hosted in Azure. This is something that they would probably use to simulate that kind of failure because it's important for the entire organization. But the smaller clients, right? So smaller organizations most likely won't benefit as much if budget is a problem, right? So it follows a pay-as-you-go model, right? So you pay for the execution of the test, and to be more specific, you pay for every action minute, right? So every action is the task that's actually taking place in the experiment. So shutting down the VM, killing a process, that kind of thing. And in addition to that, you also have to factor in the cost of the stress that's being applied to the resources. So it's not just the cost of Azure Chaos Studio, the experiment itself, but if you're injecting, if you're adding latency to a network, right, those associated costs also need to be factored in to be able to execute the test, right? And you don't get a crazy bill, or at least you know that you're going to get a crazy bill at the end of the month, at the end of the cycle. Okay, so that's something to take into consideration. So to sum things up, right? Failure and preparing for failure, I should say, is very, very important, right? And Azure Chaos Studio gives that possibility to inject faults in a controlled manner, right? And the cool thing about it is that you can control the blast radius, right? So you can define which resources are going to fail for how long and in which manner. You don't need custom scripts, right? You can use the built-in fault libraries, and you can leverage the REST API in Azure DevOps for that. And of course, just to have a general understanding that focusing on resiliency is very, very important, and it's a preventive measure, not something that should be assumed, but rather tested. Okay. And that's all that I had for you guys. Again, thank you to Canadian Cloud Summit and to the sponsors for making this possible. And if you guys have any questions, you can just